Hello and welcome back to Anton Math. Now in this video I'm going to talk a little bit about the set of numbers that we call complex numbers. Complex numbers because they're not very simple. Now complex numbers, there are these two component numbers where one of the components of the number is what we call the real component. And one component is called the imaginary component. And the way that we denote this set is, with a capital C, or sometimes you'll see this C, the bar notation with this bar. And that's going to be equal to all these numbers of the form a plus bi, where a and b are both real numbers, and I squared is equal to -1. Now you'll commonly see as a rule here that I is equal to the square root of -1. But just a little aside, for those of you who have recently taken pre-calculus or who have taken complex analysis, we know that the square root of -1 actually has two values, doesn't it? It's equal to either positive I or negative I. And in the real numbers, we define the square root of a number to be the positive value of that square root. But in complex numbers, we don't have, that kind of number line. We don't have such a direct way of comparing two numbers, and it gets a little bit shady. It's kind of a debatable point, but I just cover my bases. I squared equals equals -1 is how I like to define this. Now we typically denote these complex numbers with the variable z, just lowercase z, and so we say z equals a plus bi. Now with the real numbers, we know that all the real numbers we can write on a number line. With complex numbers, we can't really write complex numbers on a number line, but we can graph them on a plane, right? So if we have this complex number z, I can, have some point out here z equals a plus bi, where, a is going to be this distance along the x-axis, and b is going to be this distance along the so-called y-axis. Now what we call this x-axis is not really the x-axis, it's called the real axis. We know that RE. And this axis up here, this would be y-axis. This is my imaginary axis. Okay, so instead of a number line, for complex numbers we have a number plane called the complex plane. Okay, and I'm going to use this here in a future video here in a little bit. But let's make note of something else. Notice that if I write the set of complex numbers a plus bi, where a is a real number, I squared equals -1, and b equals 0. Well, that set is the exact same as the set a, right? b is 0, so there's actually nothing here. A such that a is a real number. Or in other words, the set of all real numbers, right? So in the complex plane, you can think of it this way. In the complex plane, when b equals 0, we have this real axis. This is exactly the same thing as our real number line, isn't it? So we see that, in fact, the real numbers are a subset of the complex numbers, aren't they? So here I'm going to go ahead and complete my chain. So in the special case when b equals 0, all the complex numbers are actually real numbers, and I can get any real number that way. So let's go ahead and, this is a pretty short video, I'm going to go ahead and summarize what we've done so far in all of these videos where we've briefly talked about these different number sets. We have our smallest number set we talked about, that's the natural numbers. Right, we have our natural numbers, that's all of the positive integers. So that's a subset of the non-negative integers, right, or the integers greater than or equal to 0. And remember, we can also write this. This is equal to just the natural numbers union, just the one element 0, isn't it? Remember, this is how we glue these two sets together. Now, these non-negative integers, that's a subset of the integers. Okay, and the integers we know are a subset of the rational numbers. We learned that in our rational numbers video. In the last video, we noted that the rationals are a subset of the reals, right? The real numbers are actually just the rationals and the irrationals. Now, the irrationals don't really have a place in this chain because the irrationals are a subset of the reals, but none of these numbers here are irrational. So the irrationals are kind of off to the side here, right? And then the reals we just learned are a subset of the complex numbers. Okay, so this is a very important chain to remember. We have all of these different number systems, and the more to the left we go, the more specific we get, and the more to the right we go, the more general we get, right? Complex numbers include all the reals, all the rationals, all the integers, and all the naturals. All right, now we're going to get out of these number systems in the next video and just start talking about some of the basic properties of these numbers. And again, it'll be a review for a lot of you, but you may appreciate the refresher. So we'll see you there.